compounds. Okay, first thing we're going to look at, ternary acids. Let me write you the list, and this is the need-to-know list, and yeah, it's in my notes. And this is not everything that is in the textbook. I'm picking out the ones that are the most common. Okay, before I get any further, I want you to see the pattern here. When you have a ternary acid, you've got an H in the front, you've got an O in the back, always, 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 and you've got some nonmetal in the middle. Okay, when you have sulfur in the middle, two are found, or two exist. Down here, here's another two of the ternary acids. You see the H's out front, you see the oxygens out back, and we have a nonmetal in the middle. In this case, it's nitrogen. That's what's found to exist. Okay, for naming here. Okay, you never, never, never say hydro for these. And my students love to say hydro. They love those prefixes, they overuse them, like the monodi-tri and so forth, like Nikki tried to use with calcium oxide. We don't use it there because it's not two nonmetals. Okay, for a ternary acid, you never say hydro. For a binary acid, you always say hydro. Think of two acids you have used in the lab. You've used HCl, hydrochloric acid, it was binary. You've used sulfuric, I believe you've used sulfuric acid, H2SO4. That's its formula. Ternary, never, never, never say hydro. So here, notice, here's our language. First of all, we still always say acid out back, and then we use the us and ick one more time. Okay, over here. Now, for the binaries, they always use the ick. Just arbitrary, they decided to use the ick. When we were working with cations, we had these endings, us's and icks, and it meant lower and higher. We have something comparable here. Lower number of oxygens gets the us. The lower gets the us, the higher number of oxygens gets the ick. So, sulfurous acid, sulfuric acid. As far as us working in the lab and in everyday life, this is the more common of the two. Sulfuric acid, that's battery acid for your car. Now, these two. Let's try this again. Strong or weak? Must not be looking at your notes anymore. Strong or weak? Weak. Strong or weak? Strong. Okay, now with nitrogen, that's going to be nitrous, because with nitrogen, see it's 2 and a 3. That's just simply the facts. Okay? Monkeys are found with tails. We have no tails. That's the fact. Alright? Nitrogen is found with 2 or 3. That's the fact. Sulfur is found with 3 and 4. That's the fact. Okay, if this is nitrous acid, this must be what? Nitric. And you have used that in lab 12. That final step 5, I believe you used some nitric. It's by far the more common of the two. Okay, now let's move on. When we have carbon in the middle, lucky for us, there's only one that exists. And it's H2CO3. And they chose to use the ick. I mean, that's just arbitrary, because usually ick means the higher. Well, if you only have one, they had to choose to use the us or the ick. They chose the ick. So carbonic acid. Notice, no hydros at all. And let's see, then we have H3PO3, let's do lowers, and then let's do higher. If we have phosphorus in the middle. Phosphorus, you can read my writing there, phosphorus acid, and this would be called what? Phosphoric. Okay, and this is the more common of the two. This is what's in all your cola beverages, Coca-Cola, Pepsi-Cola, whatever, kind of supposed to be a little pick-me-up sort of thing. Okay, so there's with that. And then, life gets more involved. If you have a halogen in the middle, and I'm only going to show one halogen, but it would be true of any halogens, 4 can exist. I'm going to take chlorine. Okay, now let's go back up here. I don't think I pointed at these. Strong or weak? Weak. Strong or weak? Weak. Strong or weak? Weak. 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 Okay? Weak, strong. Weak, strong. With phosphorus there, hey, they're both weak. If they're tossing that in your Coca-Cola, chances are good it's not strong. Okay, then these, my God, what do we do with them? Because the S and the ick is not going to completely cut it. So here's what they did. The two lowers, they did give the S's. So let me start here. We have chlorous, acid, chlorous, acid, chloric, acid, chloric acid, but of course that's not going to cut it because you can't have two compounds with the same name. And so what they went to are some brand new prefixes, in this case only, that we haven't seen before. For the lowest of them all, hypo, hypochlorous acid, hypo. Here's a word maybe from everyday life for you, if you're in the medical profession or thinking about it, or somebody in your family, if they have low blood pressure, they're hypotensive. And if they have low blood sugar, what is it? Hypoglycemic. Hypo means low. Okay, then, this one just stays as is. This one stays as is. For the very highest of all, if chemists were logical and consistent, they would have said hyper. But hey, no. Could they be that easy on you? No. They just say per. So, per, let me write that a little better. Perchloric acid. Hope I didn't just throw my last one away.